Okay, so here we go. This is problem number 7, okay? Well, last time I gave you this problem, and I asked you, well, is it possible for this particular truck to carry this load of 35 TVs and 25 microwaves all at once? And what kind of information is given in this problem? We know for a fact that this delivery truck cannot carry anything over 4,000 pounds. That is its weight limit, 4,000 or less. With that information alone, what kind of symbol do you think we should use to represent 4,000 pounds or less? Yes?
Less than or equal.
Very good. So less than or equal. So we know for a fact that at some point in the problem, an inequality problem anyway, so we're going to have to use the symbol less than or equal to represent less than or equal to 4,000 pounds. What else do we know about the problem? Besides knowing that it's trying to carry 35 TVs and 25 microwaves.
This limit is 4,000 pounds.
I know, we just said that.
Oh, okay.
What else do we know about the problem? Did you read the entire thing? Did you actually analyze each part of the problem? You see, that's why I'm trying to get you to see that. Yes, Elijah. I'm sorry, not Elijah. Isaiah.
You're the weight of the TV.
What was the weight of TV?
The weight of the TVs and the microwave. The TVs are 77 pounds per TV, and microwaves are 25.
Okay. So we consider this to be fixed weight for each item? It cannot change, right? If I make that TV, it's going to weigh 70 pounds. With very small margin, we talked about margin of errors before. Well, 77 is about the weight that we are considering for this particular problem. And so so we know the background is this problem. Let's start analyzing this. So first of all, here's the first question. Will the truck be able to deliver 35 TVs and 25 microwaves? So how do you actually find that out? What kind of method is involved here to figure out the weight of 35 TVs and the weight of 25 microwaves? Anyone over here? You're all like quiet. How do you figure that out? How do I figure out the weight of 35 TVs knowing that each TV weighs 55? 77 pounds.
Multiply it.
Multiply what by what? What is it?
25 by 55 from microwaves.
Okay, so you say for microwaves, I will take 25 microwaves, right? Times it by
77. No, 55.
55. Okay, let's figure that out. What is that? So this is for microwave. Micro. Okay.
Okay, that's 25.
Okay.
Yeah, 25. Carry. And put 2, so 5 times 2 plus 2 is 12.
Okay. So since this is also 5, the same thing, right?
Yeah.
So 5, 2, 1. Do we all agree? Mm-hmm. This is how we do the math, right? Notice I'm trying to teach you to do the math as well. We add that, it's 5, 7, 3, 1. So basically it's 1,375 pounds. So this is the weight for 25 microwaves. Agree? We all know how to do this, I hope. This is just simple math. And so how do we calculate 35 TVs? Yes, Isaiah.
Multiply 35 by 77.
Okay,
yeah,
good.
You want to copy me? Yeah.
For TVs, we take 35 TVs times it by its weight, which is 77 pounds for each TV. So let's do that math. What is that? 35. So 5 keeps a 3. 24. Very good. And it should be the same thing for the bottom as well. 2, 4, 5. Let's add that. Let me just make some space here. You can actually see. What's that going to get us? 5, 9, 6, 2. So 2,695 pounds. So, how do we calculate so that we can figure out weight? Is it possible for this truck to carry this much weight? Yes.
We have to add.
We have to what?
You have to add the 2 pounds.
Okay, two total pounds together, right? So on one end we add the total pounds of 25 microwave, which is 1,375 pounds, and we also add the weight of 35 TVs, which is 2,695 pounds, and the total weight comes out to be 4,070 pounds.
No, it can't carry it.
It's not reasonable.
So, what does that mean?
It can't.
So if you're the driver of this truck, you have to decide, okay, what is that one item I'm going to have to get rid of so that I can actually carry the rest?
TV.
Is it one microwave or one TV that I need to get rid of?
TV.
Why TV?
77.
So if I get rid of one TV, what's my weight now?
3,900.
And
93.
Okay, good. So that means this truck can carry how many TVs?
76.
How many TVs can it carry?
30.
34 TVs and
25 microwave.
and 25 microwaves.
Okay.
Let me ask you this question. Is this the only possible answer for this problem?
No.
What can change?
The microwave.
The microwave or the TVs? Is it fair to say that, hey, I can technically carry nothing? 0 TVs, 0 microwave, that's definitely under 4,000 pounds. What else can I carry?
1 microwave.
1 microwave,
0 television.
0 television, so that's another possible solution. What else?
2 microwaves.
My 2 microwaves.
Then 1 television.
Yeah. So do you agree with me that you can actually sit here all day long and just name that? I can carry 3 TVs, 1 microwave, 4 TV, 1 microwave, and it's still going to be under pounds. Is that true? Is that correct?
Yes.
Okay. But that's not the point. That's too long. I mean, you're not going to sit there and guess all day long. This is the reason why they said, well, okay, so far you have named like at least 4 or 5 possible solutions already, right? Now, we want to get to a point where we want to make an inequality to represent all the solutions, not just you sitting there and naming each solution, all right? So how do we actually write up something that can represent all solutions? In this case, let's think about this. Let's go back and analyze our problem. Given the fact that we have to take the number of TVs or microwave times its weight, what value here will stay fixed throughout the problem? I mean, it would never change. Which is what? What is that? What's that 55?
The weight of the
The
microwave.
weight. So the weight of each item will stay constant throughout. Is that true? What can change though? What could be different? The number of microwaves and number of TVs. So do you agree?
That's a microwave.
Do you agree that for this 25 right here, that number can change? Is that true?
Yeah.
If it can change, always think of this. If a value can change, I mean, it can take on different values. If it can take on a different value, what's the best way to represent something that can change? A variable. So can we say that instead of writing 25, can we just represent m as the number of microwaves? This is how we declare our variable. So m, I would just write that. So I'm going to write m is the numbers of microwaves. Okay? On the TV side, what can change? The number of TVs. So instead of saying 35, what can I use for 35? T. So I'm going to say T, which is the numbers of televisions. Right? We all agree? So we take that now and go back to the actual problem. How do we figure out the weight of m microwaves? Very good. So we agree that we say this, 55 times m, we figure out the total weights of whatever number of microwaves that I'm going to have. Is that true? And what about televisions? Okay, so add the weight of each television, and I don't know how many, so I'm just going to say 717. They're all good? If we add them all up, what is it that we want the weight to stay under?
4,000.
4,000 pounds. We want it to stay under 4,000 pounds, and we all agree what symbol should we place in here? Less than or equal. And guess what? We just figure out an inequality to represent all of the solution for the problem. You see that? So that means, what does it mean? As long as I can take the number of microwave and the number of television here, plug them in, and it still stays under 4,000 pounds, we have a solution. That is our solution. Any questions so far?
Is that a 4?
Which one? Oh, it is 4. 4,000 pounds. Okay, right? So here, we can sit here all day and we can name solutions. And honestly speaking, you can have infinitely many solutions, right? But here's the question. But are they all reasonable solutions? Can you give me a case where it is a solution, but it's not reasonable? Yes?
One TV and
That's still reasonable. It works.
Why would you carry like one TV? Yeah, why would you carry one?
Why not? But it works, right? You can technically have one TV. This whole truck can carry just one TV.
But like if it's right there, like if we go turn,
Yeah.
No. Think of it deeper in this case. We're talking about mathematically here. What is it that mathematically possible, but not reasonable in real life? Yes.
No TVs and no.
But that's
That's
still reasonable. You can have empty truck. Yes. Decimal. Very good. Is it true that technically, mathematically, you can have 5.6 TV and 2.3 microwave, which is still stay under 4,000 pounds? But in real life, is that reasonable to have 5.6 TV and 2.3 microwaves?
No.
What about, you forgot about negative numbers?
What
Is it
about-
true that if this is negative, it's definitely going to be under 4,000 pounds?
Yeah.
Is it possible for you to have negative 5 TVs and negative 6 microwaves? You see what I'm saying?
Yeah.
So for this particular one, even though it's mathematically possible, because it's still true, but being that we talk about a real life problem like this, the math is not reasonable. And so sometimes you gotta kind of filter through and say which one is reasonable and which one's not. Yes.
What if it's decimal because it broke?
Come on, just try to be reasonable with me. Any questions so far? We're good?
Yeah.
Okay. So the next piece of this problem is, once you've come up with an inequality such as this, I want to show you how to actually represent it using a graph to really make sense of it all. We know, we kind of expect what solution we're going to see here. We want a TV to be 34 or less, and definitely 25 microwaves to stay under that 4,000 pounds. So basically anything under 34 TVs and under 25 microwaves, that is definitely a possible answer. Or if you have 0 TV, you can certainly carry a lot more microwaves. Is that true? So the answer can change, but we at least be able to anticipate what kind of answer we get. But for today, guys, we're going to take that inequality right there, and we're going to convert that into a graph, and I'll show you what it looks like. Okay, so let's move on to the next page here, and I'll show you what it looks like.
I want to be in some movie, like when you turn, the whole class turns, and I'll be like that noise.
If I can actually, there you
I
go.
wanna see a
Okay.
movie, when you turn, the whole class turns, like makes that like switch noise.
Okay, thank you, Satino. So let's go back and write that inequality. What is that again?
Inequality is
What is the inequality that we just wrote? 55 M for the weight of the microwaves plus 77T less than or equal to 4,000 pounds. So this is our inequality. So when do we know to, okay, let me ask you this question. When do we know to graph it on a two-dimensional plane with just X and Y axis versus a number line? Typically, I'll tell you, hey, graph this in a number line. And a number line usually involves only one variable. I said usually. Not always true. Usually involves one variable. But most likely, like 100%, when you see two variables like this, you will have to graph it on a two-dimensional plane, which is X and Y. So we expect this to graph it on an X and Y coordinate. But then just to really make it easier for you to graph, I would convert the variable to X and Y as well, so that you don't get confused. So what do you want to convert the M into and the T into? X for what? M. Yeah, M comes before T, just like X comes before Y. So for this particular inequality right there, I would just rewrite that to look, I'm sorry, just to, so that it's easier for you to graph. You see how it works? Because eventually we'll want to put it on this, the X and the Y coordinates. Fine. Okay? So at least now we know that the X associate with the microwaves and the Y associate with the TVs. You see it? For those of you who are comfortable with the variables, you don't have to change anything you don't want to. You can certainly label this to be M and label that to be T if you want. Doesn't matter. Okay? But the technique is this. If I ask you to graph this problem, last time I showed you the slope-intercept format, right? Which is another way to graph, or do a table, or there's another method to graph. I hope someone remembers. What's the other method that you can actually use to graph? Isaiah, see. Huh? Well, no, number lines. No, that's the one-dimensional. What's the other way that you can actually use to graph? Yes. No, not that one. Anyone? Anyone? No? Okay, that's fine if you don't remember. Let me remind you. X-intercept, Y-intercept. Remember how to find the x-intercept?
Yes.
What? What do you say? What? If we want to solve for the x-intercept, what do we have to do? I know we solve for x, but then what do we do with the y then? Okay, think about this. If it's on the x-axis, which is the x-intercept, what will happen to the y? What is the value of y? 0. So that means if we want to solve for the x-intercept, y will be 0. Did we learn this before?
Yes.
Yes. Now let's remember this again. So let's do that. If we solve for that, that means y will be 0. If y is 0, can we just ignore that term completely? So we end up with just this. 55x, watch what happened. Why did I actually ignore the inequality sign? What are we solving for? Just 1 point. If we solve it just for 1 point, one solution, equal, okay? We're not solving for like a whole bunch of answers, just once. Therefore, notice for when we solve for the graph, I just ignore the inequality sign. I just solve it as an equation, okay? So let's divide. What is 4,000 divided by 55? Anyone?
7. 5. I'm guessing.
7.
7.
Okay, so roughly, if you just estimate it, roughly 73 if you round it. You can verify that if you want, certainly. Okay, and how do I solve for the y-intercept? What do we do with the y-intercept, guys? X equal to 0. So watch what happened. I said x equal to 0. That means this term will go away. Is that correct? The x term will go away. So I end up with just 77y equals to 4,000. I do the same thing. I divide both by 77. And the answer comes out to be roughly 52, if I round it. Okay? How do we put this together to form a point? For this, for the x-intercept, what's the point going to be? 73? 0. What about the y-intercept? 0, 52. This is actually a very good technique to use to graph a problem like this. Figure out the 2 points, connect, pick a line. Done. Okay? So here we go.
Divided by 10.
So 73, 0, I can certainly jump by 10. So let's say 10, 20, 30, 40, 50, 60, 70. So 73 is roughly right here. Fair enough? And for 0, 52, here's 10, 20, 30, 40, 50, 60. So 52 is roughly right here. So I got my 2 points. What do we do with the 2 points now? I connect. Okay, so here's this part where I start bringing your attention to the details of the problem. Remember, we're not graphing just an equation. We're dealing with an inequality, and inequality has different symbols. Okay? Just like how we graph it on a number line. For certain symbol, we use open circle. For a certain symbol, we use solid line. When do we use solid lines? Closed circle. When do we use closed circle? It has the equal signs, right? And when do we use open circle? Doesn't have it. So in this case, when we have the equal sign to it, we use a solid. Instead of using a solid circle, we use solid line. And when we don't have the equal, instead of using open, we use broken line or dotted. So I'll show you another case when we use the dotted. But for now, because we have the equal part to it, we just have to make one solid line to represent that graph. It's off. I know it's a bit. It's fine. Okay, question so far. Solid line, just because of the equal, just like a solid circle, closed circle. Same kind of deal. All right. So I want you to think about this for a moment. Now that we're dealing with inequality, we don't just stop after we graph the line. We have to do something more than that because we just figured out that we have more than one answer. We have a lot of answers. And we have to represent that answer some way. And that way is by shading the graph. Okay? And the way that we test the shading part is quite easy. Just think of this way. This line right here is just like Fruit Ninja. It's like you cut it, you know? Like cutting that two regions into half. Okay? Think of this right here. It's like your fruit on this line right here. Just like that. You're just cutting it. Now, you cut it. It separates the region into two parts. The lower part and the upper part. All that you need to do now is pick a region that contains the easiest point to test. Which region do you think is actually the better region to test? Why? Yes, it has the smaller values. Usually the small value is good because notice that if you pick bigger value to plug in, it's gonna be hard for you to calculate. Not that it can't be done, but it takes longer. So you want to pick a region that's easier to test. In this case, the bottom region. Please do one more thing for me. Never pick up a point on the line to test. Just make sure you stay off the line, okay? Think of it as your boundary. Don't pick anything on it. So in this case, I'm picking the lower regions. Which point would you like to pick to test? Okay, so you're saying 0, 0. I'm going to go ahead and pick 0, 0 right there. This 0, 0 is in the bottom regions, and it represents the entire deal. As long as I can verify that it's representing something, I'm all good. So watch what happens. If I take 0, 0, I plug it back in here and test. So that means 55 times 0, right? Plus 77 times 0. 55 times 0 is 0. 0 plus 0 is? Is 0 less than 4,000? Yes. You
No.
just
Just kidding.
Okay. You just verify that, yeah, indeed, what I just tested is true. And so here's the next part. I have to show that if it's true, I have to show something, like a sign, sort of. And this is a sign that you show. All you have to do is shade it. And this is how you show that it's true.
Oh, teeth.
Okay? Now, what does it really mean? Think about this. Remember all the solution that you gave me from before? Like, oh yeah, we can pick 0 TV and 2 microwaves, or 5 microwaves and 6 TVs. Notice that all those solutions actually stay in this area. That's why it's all true. Okay? Give me another solution. That's possible. Let's stay under 4,000 pounds. 1, 1. Look, isn't 1, 1 actually in here too? In the shaded zone? What else? 10, 10. Look, 10, 10 is still in here as well. So everything that's in that shaded area is actually true to the problem, because the problem tells me that as long as it stays under 4,000 pounds, we're all good. And that means any point in here stays under 4,000 pounds. And we talk about answers that are not reasonable. For example, it has negative answer as well. And we already talked about that. We cannot have negative 5 television and negative 4 microwaves, right? It's a possible answer, but it doesn't make sense. We cannot have decimal for the number of TVs or microwaves either. But it's still within our possible answers, but not all of them are reasonable. Okay? And this is the kind of thing that I want you to be aware of. Any questions so far on the shading? Oh, imagine, let's say this. Someone in this class picked this region to test, and you figure out that this is false. What does that mean? And the other side's true. Remember, only represent the part that's true, that means shaded. Don't ever do anything with the false side. Leave it alone. Okay? Any question on this?
No.
Okay, so let me give you a case where you have to use dotted line, and we'll go on from there. Any questions at all? We're good? All right, watch this.
Watching.
Yes. So here's a case that's actually a bit easier. Let's say 6. How about that? Yeah, sure. Why not? Okay. How do I graph?
Y, X.
Okay, so we know we're gonna have to put it on here. But we need 2 points, right? How do we find that 2 points? Okay, find x-intercept. How do I solve for x-intercept again?
Y equals 0.
Y equals 0, so that means the y part of this will be false. Will be 0, right? So that means the equation now will look like what?
Negative 2x.
Negative 2x.
Greater.
We don't care, remember? We just solved for a point.
Equals 6.
When we solve for a point, we don't care about the inequality sign.
And then divide.
Okay? Then divide by negative 2. X is negative 3, so how do we put this up as a point?
Negative 3 equals 0. I mean, yeah.
Not 0. Negative 3, 0. X-intercept. If it's x-intercept, x has to go first, and there it is, right? For the y-intercept, what is x equals to?
X equals 0.
Very good. Okay, and what does that mean in terms of x equals 0?
3y
Okay.
equals 6.
That means the x term will go away. Okay. Divided by 3. Y is 2, and how do I put this point up? 0, 2. Questions so far? No. I got my 2 points, right?
Yeah.
Good enough. I plot them.
Yeah, homie.
Negative 1, negative 2, negative 3, 0. Right there. Right? And what about 0, 2? 0 and 2 up. Okay. Got my 2 points. Watch what happened. This is a crucial point. I look at the symbol, and it doesn't contain the equal part to it. Therefore, I use what kind of line? Dotted line, or broke it. There. That's how I tell them apart. So when we have the equal part to the inequality, we use a solid line. If we don't have the equal part to it, we use dotted line. Okay, and now let's figure out which region should we test. Which region? The bottom. Okay, the bottom. Pick the bottom. Remember I told you, let me remind you again, do not pick a point that's on the line. Do not do that. It has to be off the line. The line is just like your cut. Don't. Okay, so you pick what?
Bottom.
The bottom. Okay, so you said you pick the bottom, you test out 0, 0, right? I'm going to take that 0, 0 and plug it in where?
X and Y.
X and Y. Don't forget to plug it in the correct place. So here it is. 0 for X, 0 for Y. Is that going to give you a true answer?
No.
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 Why?
Because it's
It's all zeros.
0 is less than 6, not greater than, right? So therefore this is false. So you pick this point, you tested it, and it's false. That means which region must be true? The top. So if we say that the top is true, how do we show that? Shade it in. So to complete it, we just have to shade it in. That means any point up here, when you plug in, will be a true answer. That's all we're doing. Any questions so far? What question do you have for me based on that? Is that straightforward enough?
yes.
Yeah.
Yes. It's the same thing.
I'm a cowboy.
Yeah? It's pretty much the same thing, except for you need to watch out for the line. When we get to tomorrow, we will have to work backwards, by the way. Meaning, if I just give you the graph, can you give me back the inequality?
Yes.
It's a bit more challenging, by the way, and it needs a bit of a review on your part on how to come up with your own equation, by the way. Okay, no other questions?
Can you give us an example
Are we done?
of that?
Are we done?